So friends, welcome once again for this worm and worm wheel fifth lecture. So during last lecture we have seen the assumptions in case of force analysis, and inside that force analysis assumptions we have seen that worm is driving element and worm wheel is the driven element. Worm has right-handed threads, worm rotates in anti-clockwise direction. On this particular figure we have seen here. So this is about worm and worm wheel. Okay. So here if we consider the different component of forces, then already we have seen that tangential component of force, axial component of force, as well as radial component of forces. One represents the worm and two represent the worm wheel, and the particular relationship between tangential axial component of force, because in case of worm, if we consider this as a tangential, then that becomes axial in case of worm wheel. Is it okay? So that's why this particular axial tangential component of forces we should understand. The same thing in three-dimensional cases we can observe here. So this is the tangential component of force which becomes axial component of force here. So tangential component of force in case of worm wheel, which is the axial component of force in case of worm. This is a radial component of forces for both, and this is tangential component of force for worm, which becomes an axial component of forces. Okay, so that's why the relation we should understand here is P2T is equal to minus of P1A. This indicates the sign and magnitude is same. Similarly, P2A is equal to P1T and P2R is same equal to P1R. Is it okay? So while force analysis of worm type, one more thing we'll have to take into consideration, that the resultant force acting on worm consists of two components. So that is very important step that we should understand properly. A resultant force acting on worm consists of two components. Components of normal reaction between meshing teeth and components of frictional force. Is it okay? So two components, out of which components of normal reaction between meshing teeth. So that regularly we are considering as part of force analysis. One more component we'll have to take into consideration, that is the component of frictional force. Is it okay? So that is very important. The two components are superimposed to get the resultant component. So resultant component will be identified based on two components of, one is the normal reaction between meshing teeth and another is the components of frictional forces. Is it okay? That should we understand. Similarly, the component of normal reaction acting on the worm, that should be considered here. So this is a very important figure that we should understand the different component of forces in case of worm. If we will observe here, then if this is the axial direction, then along this axis this is the axial component of force. Always tangential component of force is tangent to this particular circular shape, and along the radius this is the radial component of force. So axial component of force, tangential component of force, and radial component of force. So this is three-dimensional forces which are acting on the particular worm as well as worm wheel. And if we observe this total diagram as a three-dimensional diagram, then this triangle ABD, which is shown here as a triangle ABD, is it okay? Inside which AD represents radial component of force and AB, so which is shown here as a normal component of force. Here we can observe that this DC, which is the resultant of PT and PA. Is it okay? So this is the tangential component of force, axial component of force, and the resultant is here a normal component of force. So this PN is shown here. So AB represents PN, AD represents PR, and resultant of all these three forces, axial, radial, as well as tangential component of force. For all these three component of forces, BD, which we will consider as a solid diagonal of this particular three-dimensional figure. Is it okay? So BD is the solid diagonal, and BD will be considered as the resultant of all the forces, that is axial, radial, as well as tangential component of force, out of which AB represents the resultant of axial and tangential, and AD represents radial component of force. So radial and normal component of force, resultant of that is considered to be P, and which is solid diagonal BD. Is it okay? Now here you may consider that this particular component of forces inside which AB and BD, so this particular angle AB and BD, So this angle is alpha. So alpha is pressure, normal pressure angle, that we know. Is it okay? So normal pressure angle is alpha. At the same time, we should now consider this particular AB. So this figure which is shown here, AB, is it okay? Then AE. So this particular top view, we may consider this AE, then AB and AF. So top view of that three-dimensional figure. Is it okay? Inside which this angle between EB and BA, that angle is gamma angle. Is it okay? EB and BA, so which is shown here, this particular view only, that top view, EB and BA, so that is gamma. We have considered that gamma as a lead angle. Is it okay? So PN, PT and PA. So this is axial component of force, this is a tangential component of force, and angle between this EB and BA, that is gamma, which is shown here. Is it okay? Now with reference to these figures, now we have to identify the relationship between normal reaction P in the plane ABCD here as shown here. So this Pn, now we are representing this, we are referring this figure B, and with reference to this figure B, now Pn is P cos alpha. Is it okay? Because BD is considered to be resultant component of force P, and angle between Pn and P is alpha, that is normal pressure angle, and that's why this particular AB is BD cos alpha, or we may consider Pn is equal to P cos alpha. At the same time, with reference to this figure B, we may consider that PR, radial component of force, which is P sin alpha. Is it okay? Here we may consider this is a radial component of force and this is angle alpha. If we take sin alpha here, sin alpha is PR upon P, or indirectly we may consider as PR is equal to P sin alpha. Is it okay? So with reference to this figure B, we have two relationships, Pn and PR. Is it okay? Now we will refer this figure C. Is it okay? With reference to this figure C, now axial component of force, which is shown here, AF is the axial component of force, PT is, so this EA is the PT, tangential component of force. So here if we refer the relationship between axial component of force with reference to this Pn, then PA and Pn, so this particular angle is gamma, so here also this angle is gamma. Is it okay? So angle between AB and AF, angle is gamma. So that's why here we may consider that PA is Pn cos gamma. Is it okay? If we consider this angle as a gamma angle, and if we take this angle as a cos gamma, then cos gamma will be this particular AF divided by AB, or PA divided by Pn. So that's why we may consider as PA is equal to Pn cos gamma. At the same time, relationship between PT and Pn we can identify here. If we take sin gamma here, then that sin gamma is nothing but PT upon Pn. Is it okay? Sin gamma is equal to PT upon Pn. So that's why PT is equal to Pn sin gamma. Is it okay? So these two relations we are getting with this figure C. So Pn, PR, PA, PT, these relationships we have given the name as equation A, B, C and D. Is it okay? With reference to this figure B and C, we have identified these relationships. Now here, if we consider the D, inside that D we are considering PT is equal to Pn sin gamma. But Pn is P cos alpha. So if we substitute P cos alpha here at the place of Pn, then tangential component of force PT becomes equal to P cos alpha sin gamma. Is okay? Tangential component of force PT is equal to P cos alpha sin gamma. At the same time, PA is Pn cos gamma, and Pn is given as P cos alpha. So if we substitute here P cos alpha at this place Pn, then it becomes P cos alpha cos gamma. Is it okay? So tangential component of force and axial component of forces are given as P cos alpha sin gamma, P cos alpha cos gamma. And at the same time, radial component of force is P sin alpha. Is it okay? So PR is equal to P sin alpha. This is equation B. So tangential component, axial component and radial component of forces are given with the help of these equations. Is it okay? But as already decided that resultant component of force, so that will be considered with reference to two type of forces, out of which one component of force will be considered as the force which is in between the different component of forces, and another is resultant frictional force. Is it okay? So resultant frictional force mu p, where mu is coefficient of friction. The direction of frictional force will be along the helix and opposite direction of rotation. Is it okay? So there are two component of frictional forces. Now you will refer this particular figure. Suppose this is the resultant force acting on the this is frictional force. Is it okay? Frictional force is very important. We should consider in case of worm and worm wheel, because there is surface contact. So this particular component of force we should consider, that must be considered here. Without that we will not get the exact answer of different component of forces. So that's why mu p, as usual we are considering frictional force as mu p, where mu is the coefficient of friction and p is the resultant force acting. Is it okay? So here resultant frictional force mu p, where mu is the coefficient of friction. Is it okay? So this particular mu p has two components, mu p cos gamma and mu p sin gamma. So angle between mu p and mu p, here we have considered the gamma lead angle. Is it okay? So that's why this is resolved. So mu p is resolved as mu p cos gamma and mu p sin gamma. Now here if we observe mu p sin gamma, then that becomes in opposite direction to axial component of force. Means here if we refer this figure, this is axial component of force, and mu p sin gamma, which is shown here, that is opposite to that. At the same time, if we observe here this particular ED, this particular line, if we join this line ED, which is the resultant of this radial component of force and tangential component of force, then mu p is same in the direction of ED. Is it okay? So mu p is cos gamma is in the same direction on this diagonal. Is it okay? So that's why while considering the resultant forces, means we will have to superimpose the component of normal reaction and frictional force. Means here before we have not done this practice for other type of gears, but in first time we are considering superimposing concept in case of normal reaction and component of normal reaction and frictional force. Is it okay? So that's why tangential component of force in case of worm is we will have to superimpose. That means we will have to add both the things, that is mu p cos gamma will be added, and this mu p cos gamma which is added in p cos alpha sin gamma. Is it okay? So here p cos alpha sin pt, tangential component of force is p cos alpha sin gamma, plus additional this mu p cos gamma will have to take into consideration. So resultant tangential component of force in case of worm, that is given as p cos alpha sin gamma plus mu p cos gamma. Is it okay? So p is taken common, and then in bracket cos alpha sin gamma plus mu cos gamma. Similarly, axial component of force, in that axial component of force we should take into consideration p cos alpha cos gamma. So p cos alpha cos gamma is taken into consideration, and this mu p sin gamma is in opposite direction as already discussed. So that's why this is taken in negative direction. So axial component of force in case of worm is p into bracket cos alpha cos gamma minus mu sin gamma. Is it okay? So that we should understand properly, because this direction is opposite direction, so that's why negative sign is taken. And then radial component of force is p sin alpha. Is it okay? So this component of forces, force and together if we write here, then in case of worm the tangential component of force is p into bracket cos alpha sin gamma plus mu cos gamma. In case of axial component of force in case of worm, p into bracket cos alpha cos gamma minus mu sin gamma, and radial component of force p sin alpha. Is it okay? Similarly here axial component of force and tangential by taking ratio of p1a upon p1t. So that ratio is taken p1a upon p1t, and then this relation is established in between axial component of force and tangential, because we know that always we are calculating tangential component of force, and based on tangential component of force axial and radial component of forces are calculated. So with that reference the ratio is taken p1a upon p1t, and we have found this relationship p1a. Similarly here ratio is taken as p1r and p1t, and p1r is identified. So radial component of force in case of worm, so that is calculated based on tangential component of force. So both axial and radial component of forces are calculated based on tangential component of force. So that should we understand as part of this lecture. Thank you.